In chapter 1, we also talked about different exponent rules. If you're multiplying bases that are the same, or you're multiplying like bases, you want to add exponents. If you're dividing bases that are the same, you subtract exponents. Now, the only thing you have to be careful with is if there are coefficients. If there are coefficients, you have to follow the operation that's happening. So with multiplying like bases, you add exponents and multiply coefficients. With dividing bases, you subtract exponents and divide coefficients. So you have to make sure with coefficients you follow the sign that is actually happening in the problem. In example 6, when you have a parenthesis attached to another parenthesis, that means multiplication. So first thing I want to take care of are my coefficients, the 4 and the 3. Since it's multiplication between those parentheses, I'm going to multiply those values together to get 12. Now, when you're multiplying like bases, I need to add the exponents. So this is 12 to the 2 plus 7, or 12x to the 9th power. Okay, you want to make sure that your final answer does not show any of the work. Your final answer needs to be the completed answer. In number 7, we are also multiplying. That's what that dot means right there. So the first thing we want to take care of are those coefficients and do -3 times 4. And then you go ahead and take care of the variables. And I have x. Since x doesn't have a power, there's an imaginary 1 there. And the other x has a positive 2. So x to the 1 plus 2. And I have y to the 6 plus 9. Simplifying my work gives me -12, x to the 3rd, y to the 15th. Oops, sorry. Okay. Notice in example 8, that bar that goes across 8 and 9, that's a division bar. So the first thing that you have to ask yourself is what number goes into both 42 and 7, and that would be 7. So divide both the numerator and the denominator by 7, and I'm going to get 6 over 1. And then I take the exponents, and when we're dividing like bases, we subtract the exponents. So this is going to be x to the 6 minus 3, which gives me, since I have this division by 1, I don't need to write that in my answer, and I can just write 6x to the 3rd power. In number 9, what number goes both into 24 and 6? That would be 6. So I'm dividing both the numerator and denominator by 6. 24 divided by 6 is 4. 6 divided by 6 is 1. And now we go ahead with the variables and subtract them. G to the 3 minus this denominator g has an invisible 1 there. And we have h to the 6 minus 6. Okay. Now we want to go ahead and simplify our work. This division by 1 we don't need anymore, and this is going to be 4g to the 2nd power, h to the 0 power. However, you have to remember the rule. Anything raised to the 0 power is 1. So technically this piece here can disappear, and my final answer is 4g squared. Okay. Another exponent rule that we learned is a power raised to another power. If you have an exponent raised to an exponent, you have to multiply existing exponents. Okay, so what you, in your mind you can think of is you can think of it as distributing the outside exponent into each base that's on the inside. Okay. So if we notice in 10, I'm going to take this exponent and distribute it to my base x. X already has a power, and that power is 4, and my rule says that I multiply exponents. So x to the 4 times 3 gives me x to the 12. In number 11, you have to notice that there are 2 bases. So I'm distributing this 7 both to that 3 and to the x squared. 3 is being raised to the 7th power, and x squared needs to be multiplied by that 7 as well. Okay. Please note that 3 raised to the 7th power does not mean 3 times 7. It means 3 caret 7, which is 2,189. 2,189 x to the 2 times 7, which is 14. And that would be my final answer for both 10 and 11.